All right, ladies and gentlemen, this is lesson 4. I forgot to change our essential question, so we'll have to get that at the beginning of class. We are talking about special products today, so there's a couple different methods that we need to be aware of. And we're going to be using the FOIL method to help us to solve and hopefully identify these patterns, as they will help us make things a little bit easier throughout 8-4. So if you look here, if I have an a plus b squared, that means I have an a plus b times an a plus b. So my firsts, my outers, my inners, and my lasts are all color coded. So a times a made an a squared, a times b makes an a times b makes an ab, and a b times b made a b squared. So that's the algebra of this all. We can notice that it becomes the pattern of a squared plus 2ab plus b squared. Now when we have things that fall into that specific pattern, they are called perfect square trinomials. So they have to be in the form of a squared plus 2ab plus b squared. So what that means is that when we multiply the first times the firsts, we're going to have our inners and our outers end up being the exact same thing. So our firsts become the a squareds, our outers and our inners make 2ab's. So we'll show that pattern here in just a second. So here's our very first example. We can see we have a x plus 3 times an x plus 3. We do our firsts, which makes an x squared. Our outers, which makes a 3x, and our inners, which makes a 3x. And our lasts, which make a 9. Now the pattern here, folks, as you can see, is my two inners. I have a 3x plus a 3x. I can just square the first number, x squared. I can do 3 times x times 2, which makes a 6x, and then I can square the last one. So I end up with the final answer of x squared plus a 6x plus 9. Now that is a perfect square trinomial, and because we notice that this pattern takes place every time we have an addition problem that is squared, or a subtraction problem, as you will see in the next example, squared, we can just follow that exact same pattern. So we just do a squared plus 2ab plus b squared. Alright, try one on your own here, see if you can get it correct. We'll check it tomorrow in class. And here's the pattern that we're trying to show you again. This time, instead of being a addition problem, we have a subtraction problem. So you could guess that we're not going to have all addition problems when we go through and FOIL this. So again, first times first makes an x squared, outers makes a minus 6x, inners make another minus 6x, and our lasts make a positive 36. So the difference in our pattern here today, folks, is that when we're having a subtraction problem, we have a minus 2ab, minus 12x in this case, plus a b squared, because a negative times a negative makes that positive. So this middle number, if you remember from the last time, was a positive. This time our middle term is going to be negative. So again, this is still a perfect square trinomial because it falls into that category of an a squared, in this case minus 2ab plus b squared. And that's something that we need to be able to understand for us to make things go a little bit quicker, because again, math is patterns and we want to follow those patterns. So you'll try this one on your own as well. Alright, on to a new idea, something called the difference of squares. Now a difference of squares is when I were to have an a plus b times an a minus b. So my a's are the same, my b's are the same, but I have a positive and a negative b. And what happens here is if I do a times a, I get a squared. My outers, I get a negative ab. And my inners, I get a positive ab. And then my lasts, I get a plus a b squared. Now because my two inside things, one's positive and one's negative, those terms are going to cancel. So then we are, oopsie, this was a negative. I made a mistake. This was a negative b squared. So you can see after things had canceled that we're left with just a squared minus b squared. So we can show all those steps for you on this next example, but you should be able to see then, folks, that when we multiply one with a positive and a negative b, we're going to be able to cancel out the middle term. So this just becomes an x squared minus 4x plus 4x and a minus 16. Now again, like we just showed you, the middle terms cancel, so this just becomes an x squared minus 16. Now these are both perfect squares, so they're a difference of squares. So we have an x squared and a minus 16. So those are both perfect squares. That's why it's called the difference of squares. All right, we have one last example that I want you guys to try on your own. We have the job of writing a polynomial that represents the area of the yard around the pool shown below. Remember when we're finding the area of rectangular shapes, in this case they're both squares, we're going to have side times side. So to find just the unshaded area, we're going to have to do the big minus the small, and hopefully you guys will be able to show me how to do that. And that's all we have for today. Special products are just a pattern for us to realize that we can do things in a little bit quicker way after we notice that there are patterns taking place. And we will use this again in Chapter 8. Alright folks, if you missed any of the patterns, this is all the information in one last spot for you. Your homework, you notice I left it blank because I don't like it when you guys start too soon. So we'll give that to you tomorrow as well. Alright, this is Bourbon Nation signing off, guys. Have a wonderful day.